I just made a very quick test here. It took me like 10 minutes or 15 minutes to create this little logic here. What it does, it is commanded, the clock is from there through this yellow wire that is on the 7493 on pin 14 there, the last pin that is having there. And this chip is having a positive and negative here somewhere, not on the corners. So that is a clock pin that is having on the number 14. It's having a special arrangement of the pins, not like usual. As you can see here, I have two of 4017 decade counter, and I showed this in my circuit diagram already, but I made it in reality as well. Here I prepared the actual chips that will be soldered, and but before I'm doing the soldering, I said to myself to actually make a quick test on the breadboard, because it's always a good idea not to encounter some weird problems along the way. And here is the switch actually that I'm switching between powers, powering this chip or switching to power this other chip, and everything is connected between. As you can see, sorry for the glare, but the counting is, I can slow it down actually, and it will, yeah, it's good enough probably, or even more slow, yeah, like that. The counting is from top to the bottom, and then restarting from top on the bottom and so on. So this is the cycle. And now if I'm switching the chip, it is counting from the bottom to the top. 1, 2, 3, 4, you know, like that is the counting. And that's exactly what I needed. And this is all the logic that it needs to do this switching from top to bottom and from bottom to the top, pretty much. Between this, only 4 lines of LEDs. I'll make abstraction of this part here, but from here down. So this is the part that we are interested. So from this line down. That diode, yeah, I didn't really... It's working without the diode, actually, which is pretty good. I like it. Proteus is a little bit, Proteus simulator is a little bit touchy, you know, it's very sensitive. It's a bit too sensitive, but in big lines, it's working. It's working absolutely fine. I'm absolutely extremely pleased. It was a very, very good project. I really like it. And I like it because I managed to make it work in the end, you know, and now when you see it, oh, wow. Yeah, I totally like it. And also the stepping mode as well. As you can see, back. You can actually number here, 1, 2, 3, 4. It is set to count to 4. But I can make it count to 8 if you want. So this is counting to 8. Yeah, it's restarting automatically, unfortunately. And when I'm pressing the button, and it should do it 2 times here on the bottom, 1 and 2, and yeah, pretty cool. This will means these lines, these LEDs that you are seeing here, are actually the 4 lines that will go to the stepper motor, actually to the stepper driver, and that driver will drive bigger motor coils and etc. And I believe I will use this driver, I think. I'm not sure yet. Oh, I have already a logic there. Probably I will have to bypass it. I'm not sure. Or I will have to make another one. With here, this guy here. And probably somewhere there I will have to... Yeah, it's a mess. But yeah, slowly but surely, I'm making some progress. I'm making something. All right. A new day, new ideas. I was actually struggling deciding how to make this circuit, and this morning I had a brilliant idea to simulate the circuit here, to sketch it in this manner without drawing the integrated circuit itself, but do it like you are seeing it here. So it's doing exactly what that did in the previous experiment that I did, exactly that. And shit, I don't have the LEDs here. You're right. I forget about the LEDs, these 4 LEDs plus their respective resistors here. This little circle is the resistor, and this is the LED that will lit when any of these pads are activated, pretty much. When the signal is sent to any of these pads, that in turn will command the motor driver, which in turn will drive the motor. So this is the circuit that I was thinking about, and yeah, it's pretty good idea to do it like this. Very, very easy. At least I don't have to draw the chip itself and the button itself. And also, I'm having the component size as well. These are the components that I will actually use, that I have already here and already bent to position. Also, these pins are bent from this, and also on this other part, from this button here. And it will do exactly like that guy is doing there. It's having a wire underneath it here, from positive to that resistor. And so here it will be a resistor. I put a 1 kilo there, but it will be, it depends what LEDs I will drive. If it will be green LEDs, it will be less than 1 kilo. But 1 kilo for yellow LEDs, probably it will be all right. And here I will probably use green LEDs with the 470 ohms per each LED. And this is the ground. And here is a jungle of wires. Pretty much this is, I actually numerated. 0 is this pin, 1, 2, and this is 3. I have here the pin out of this chip, as you can see, 0, 1, 2, and this is 3. It's a bit yeah, I don't like it, but well, it is what it is, right? And from here, so everything that is going to this pad, 0 to 0, this is 0 for this chip, 1, 2, and 3 for this chip. Motherfucker. But here I have to inverse it from 0 is here, 1 is here, 2 is here, and 4 or 3, sorry, and 3, which is this pin here, not that one. That is the negative pin of the entire chip. So the second one here is going to the first pad here. So these two LEDs, I have an LED here and another LED here, are commanded by this switch here through this resistor 1 kilo or whatever it will be, and it will sync to ground. And for this LED, I will have to drag a wire from this pin. You see it dotted, is a dotted wire, a dotted line underneath, and it will ground here on this pad. This is a pad for ground, and also here is a pad for ground, because these are, let's see, clock enable, this guy here, and it must be grounded to the negative rail. So that is which one? Yeah, is this one here with a dotted line, which a dotted line means that it will be underneath, and it will go to another pad here, and also continuing here around the chip and making connection to this pad here, also to that pad there. Because why there? Because I will have to clip to put my power wire there and power wire there. And this is the clock that will be common here on this pin, and also this line here to this pin. And this is the power, the positive, that is going to this pin of this switch here. It's hard to, yeah, like this. I have to reposition it. Yeah. So it will go here, and the positive will be soldered to this pin, middle pin, and the other positive rail, it will go to this chip here. So it will switch between chips, and it will function exactly as that guy functioned, because I did the test and it worked absolutely brilliantly. And pretty much this is it. These LEDs, because of them, is eating a lot of space. They are too big, and they are eating a ton of space, unfortunately. And also I have to think how I will reach that pad with my soldering iron. It is quite a good distance here, and I think it will not be a problem. I will have to get from this angle to link any wire that will come to this pad, forward, outward. So pretty much this is it. This is the plan, at least. And yeah, I'm really happy with this diagram that I have right now here. It's complete. This is the complete circuit right now. It's not working. If you were wondering if it's working, it's not working yet, but it will. And it will look exactly like it is here in the end. All right, this is it for this part. A little bit of update, how the board is looking right now before I will solder the actual components and make all the wiring, because all the wiring will be a problem. And I didn't do it exactly like there, but especially for the middle pad, because I repurposed another board that I had, and I cut it, and you see, on a cardboard as well. And yeah, it's good. It's looking good. It will look excellent. It will do its job, hopefully. But everything is in place as it should be. Let me actually show you a little bit. So voila, how everything is fitting. I've only I decided to use only 2 pads for the chips. It's more than enough, and the rest will float, and I will link to them, to the pins, every necessary wire that I need. But 2 of the pads are good enough. For the button, I put 4 of the pads. Here is how it will stay and look, and well, like this a little bit better. And of course I can bend the legs a little bit to fit perfectly, but here on this side is better. And this is like a preview right now. Pretty much that's the, yeah, well, I will have to add some more components, the resistor, LEDs, but not much, a lot of wires. It will be full of wires. It will be a mess, a jungle of wires, but this is the preview, how it will look. All right. I made the board. It is switching from left to right. Right now I don't have this clock wire that I have to connect it there, but I also have to connect the positive and negative rails to there. I just made a quick and dirty test. Very dirty. I put my finger on the clock, or using a 1 kilo ohm resistor, whatever. Yeah, well, and if I'm touching it very shortly, you can see that it is counting from left to right. Okay, so from this one to this one, in that direction, towards there. And if I'm, let me show you a couple of, you see? You can sense the direction of it, even if it's very bumpy. And if I'm switching the sense right now, when I'm touching it briefly, I'm giving it some sort of impulse there. You can see clearly that it's switching, starting to count from right to the left. And you see? Yeah, sometimes it's moving so fast, it's jumping, and but it is, you see? Like that. The 1 kilo didn't really help. It's still jumpy with 1 kilo, but yeah, depends how you touch it. You kind of give it an impulse there, and it's showing that it is. And if I'm keeping it, is measuring the 50 hertz that is passing through my body from the mains, because here in my room I have, and also for this side as well, you cannot understand anything. Is the same 50 hertz. Here in my room I have this strong electric field, probably, or electromagnetic, who knows, probably more electric than magnetic. This is a communist building, and it's having very strong, very thick wires, and a lot of amperage there, and yeah, it's how it is. And yeah, it's this module is done. I only have to link it to that one, and pretty much this is it. Yeah, I'm quite satisfied of how it's looking. This is a bit too bright. I put 1 kilo. Probably I should change it, I don't know. And these are not that bright, and I put 470 ohms for them, and they're not as bright. I will see. All right, but this is how is the wiring is on this side of the cardboard, as you can see. And it's good enough, right? All right, I hope you like it, and also leave a like. Thank you very much. And I've also hooked it up as a good measure. I put the signal from there, also the positive and negative wires, so everything is working there correctly, and also here is working correctly, which is what I'm concentrated on to. And if I'm switching the sense, yeah, it's from here to here, so it's good enough. It's good enough. Don't look what is written there. It's kind of you know, what is important that is doing the thing, which is absolutely gorgeous. This is exactly what I wanted. A little bit too much wiring as usual, but this was a quite easy circuit to make. A lot of wiring, but other than that, quite simple. And yeah, actually it was a bit fun to make it, and it's even more fun right now when it's working, and everything is working there as it should be. Let's see if I'm switching to 16. Yeah, it's good enough, and I'm filming everything. I will have to link somehow this board here somewhere, probably, I don't know. And yeah, pretty cool. That is the binary counter there, and here is continuously. This is for driving a stepper motor, and I have the sense left and right, also the speed, and very quickly. This potentiometer is a bit yeah, too sensitive at its maximum points, or I didn't link it good enough correctly. Yeah, it's working. It's working. That's what I wanted to see. All right, I hope you like it, and see you next time when I will actually link it to the board somewhere there. All right.